Good day, everyone. Our today's topic in mathematics is the continuation of differential calculus. So in differential calculus, we have done what we call general method, first principle by differentiation, function of the function, which is known as the word chain rule, then product rule, and the quotient rule. That's where we stop. The next aspect of differentiation that we are going to treat now is what we call implicit differentiation. If you are talking of implicit differentiation, the equation we have in polynomial can exist in two forms. E is the one we are dealing with if you say what y equal to 3x squared plus 4. So this y is a function of what? Of x. This kind of equation, we call it what? Explicit. But in case of we have what? 3x squared y plus x plus 2y equal to what? 4. This kind of what? Of expression, we call it what? This one is explicit. And this one, we call it what? Implicit. So our interest of differentiation now is what we call what? Implicit. So let us look at how we can differentiate the what? The implicit what? Equation. We know how to differentiate what? Explicit by finding the derivative of y respect to what? To x. Take for example now, if y squared plus s squared equal to 10. Can now ask what? Then differentiate or find derivative of what? Of y respect to what? To x. Find the what? dy dx. If I give you this kind of what? Of equation to what? To solve, to differentiate. So you cannot say solution. What is the question given? Y squared plus x squared equal what? 10. We are asked to differentiate this expression. This is what? Implicit. So by applying the same general method for differentiation, which is n goes to power n minus 1, differentiate what? This y first. So let's differentiate this now by applying this same principle. Derivative of what? Of y will give us what? 2y. This is implicit. Whenever you are differentiate y, is a must, you will put what? Dy dx to the front plus derivative of x, 2x squared is 2x, derivative of 10, which is constant, is what? 0. The next step we do now is what? We are looking for dy what? Dx. This is already the formula. you now have 2y dy dx equal to what? Minus 2x. From this expression now, divide both sides by 2y. You now have what? 2y over 2y dy the what? The x. We have minus 2x over what? 2y. This will cancel this. You now have what? Dy. The x will be minus x over what? Y. That is what? Derivative of what? Of x squared plus y squared. Let us check another question. If, question number 2, if x cubed plus y squared plus two x squared plus 4x equal 0, or no, it was equal 2. You are now asked to find dy dx. If you are given this kind of expression, solve what? Solution. So to solve this, what we do? We are given that what? X exponential 3 y squared plus 2x squared plus 4x minus 2. We are asked to differentiate this expression. The first thing we do is what? Differentiate this x. By differentiate x, we have what? 3x squared divided s cube. You give us what? 3x squared. Yes. Plus 3 what? S squared. Leave the y. Plus, take what? Leave the s cube. Then differentiate y. You have 2y dy dx. Differentiate 2x plus what? 4x, this one. Then plus 4, everything equal to the what? 0. By doing this, we are looking for what? The x. The next thing that we can do is what? Let's take this, make the y dx result of the formula. You will now going to have what? S cube 2y dy dx will be equal to what? Minus 3x squared y squared minus 4x minus 4x. This will come to this side. From there, divide both sides by what? Divide both sides by s cube to what? 2y. By doing this, we have dy dx equal to the what? Minus 3x squared y squared minus 4x minus 4, everything into what? X cube 2y. So this is really the what? The final answer for this kind of what? Of question. Next one is what? Let's look at example 3. If 2x raised to power 4 y plus y square plus power 4 square minus plus you say 8x everything equal to what? 5. You are now asked to find dy dx. So if you are looking for what? Dy dx for this kind of what? Of implicit. So what are we going to do now here? Is can say what? Solution. The question given is this: 2x exponential 4y plus y squared 8x equal 5. Good. So what we do now is implicit. Differentiate 2x exponential 4 first. 2 times 4 times 2 is 8. We have 8 minus 1 here. 3 your y mean here. Then plus differentiate 2y. X raised to power 4 what will remain here. By differentiate 2 what? Y, it will give us what? 1. So 1 times 2, this. Then you will have what? Dy dx. Why should I put dy dx here? Because I differentiate what? This y alone, which is give us what? 1. So, or let me do it for the convenience sake. Derivative of what? Of this y here is what? Is 1. Good. Then move to this side. Derivative of this y is 2y dy dx. Then what else again do we have? Derivative of 8 with this. This is 0. Good. The next thing that we are going to do now is, sorry though, after put y here, in the first one what? Dy dx plus 2y. Because we differentiate this y, it gives us 1. We will put dy dx. Differentiate what? This y, we have this. So minus 8. The next thing that we do now is what? We are going to make dy dx as a formula. So what we do now, let's take this to this side first. We are now left with what? 2 exponential 4 dy dx plus 2y dy dx. This one and this equal to what? When this comes to this side, it will become minus 8 exponential 3y. This will become plus 8. Please take this out as common factor. We have dy dx. Here we have what? 2x plus 2y. The next thing will be what? Minus 8p plus 8. Divide what? Divide both sides by 2x plus 2y. So by doing that, what the next thing we have? We arrive to dy dx it will give us what? 2x plus 2y to what? Y. Everything over what? 2x plus 2y is equal to what? Minus 8 cube plus 8 we have here over what? 2x plus 2y. Good. This will cancel this. So at the end of the day, we are left with what? The y, the x of what is the common factor here? 8. You can have 8 outside. E plus 1 into what? Common factor here is what? 2. We have x plus what? Plus y. 2 here 1, 2 here 3. So the final answer will be 3x cubed plus 1 into the what? X plus y. So if you are given any question in terms of implicit, so that's how we want to solve it. So let us move to the trigonometric function of what? Of differentiation.